Hey everyone, so today I have Super Crack Dev hopping on for a coding interview. Super Crack, introduce yourself and what you like, how many leak code questions you do, what companies you're targeting, what year are you in, like, yeah, how many questions you've done. Let's get a sense of where your skill level is. You're Super Crack,
Right.
so
Yeah.
yeah, go ahead.
So I'm on my year off right now doing co-ops, but I would be in my fourth year of computer engineering with a minor in stats at McMaster. I've done 295 leak code questions.
Let's see.
I have offers from two really big companies, one based in the States, and I'm just waiting to hear about work authorization. And then I also had my final round with Amazon on Wednesday, and I'm waiting to hear back from them.
Nice. How did those go?
Uh, I had a I had Shopify. That honestly, I don't want to say really easy. I guess fair is a better word for it. Their interview process was very fair. I don't think it was anything that was unrealistic. Pretty easy technicals. Amazon, it was just an OA with two questions. I would say both mediums, also very doable. And then in the final, it's only one final round actually for Amazon. It was just a few behaviorals. I got a hard graph problem, but I'd done a similar one
I
earlier in the
see.
week, luckily. So I was able to solve it in about 15 minutes. So I'm hoping, to hear back. Good news.
I mean, you got this, man. Um, Okay, cool. Hop into my Google Calendar, or I sent you a link in the chat. When you join, don't put in your real name though. Just put in like a fake. Put like
Okay.
super crack, super on crack. Just kidding.
Wait, you put a link where?
Inside in the messages in the Google Meets,
Okay.
in the Google Meets. Yeah.
Okay.
So you're working right now. Or you're just waiting to for your.
I'm working right now, but I'm most likely switching roles for the summer.
I see. Nice. So you done 290 questions even before you graduated. Interesting.
Yeah.
Where do you think your skill level is at? Can you solve mediums easily?
I would say yeah, most of the time. Really depends on the question, obviously. Like some concepts I'm probably a little weaker on, but
I see. Okay.
yeah, I think I'm in the waiting room for the coder pad.
Let me bring you in. Super cracked. How'd you come up with that name?
It was just it was originally my real name, and I wanted to comment something on a video, and I was like,
Yeah.
shit, I don't want to dox myself, so I
Yeah.
changed it to the absolute first thing that came to mind.
That's hilarious. Okay. All right. So this is how we're gonna run this interview. We're gonna try to get through two questions. Um, we're gonna go through two questions and around the medium difficulty. I'm gonna give you 20
Okay.
to 25 minutes on each question. Question, and then
Okay.
yeah, I'll give you full feedback on how everything went afterwards. How's that sound?
Yeah, that sounds good.
Cool. All right, I'm gonna put in the very first question. So we're gonna be given a. Actually, no, I don't want to do that question. Let me see. Okay. This is the question. So we're basically given two linked lists. Um, these and then we need to add together these two linked lists and create a third linked list that comes from adding these two. Like each linked list represents some number, and we basically just need to do elementary addition on those two numbers. Pretend one linked list represents 55, and the other linked list represents 55. The the next linked list that we should output should be 110. Does that make sense?
Yes. Can I change it to C++?
Sure.
All right. I thought I copied it. Apparently I didn't.
I'll put it back in.
Okay. So 2 non-empty linked lists. So I'm assuming we're given the heads of linked lists.
Yep.
Okay. Head, non-empty. 2 empty linked lists representing 2 non-negative integers stored in reverse order. So if it was like 981, then it would actually be 189 for the nodes.
Mm-hmm. Wait, see, could you write out what you mean?
Yeah, so if numbers 981, then the list would be
Yep. Yep.
okay. Contains a single digit, and the digit is an integer.
Is a digit integer? Yep.
All right. Assume not containing zeros. Okay, so since it's in reverse, we can just start right from the head. So we given our two lists. I'll go through it with an example. Let me put in an example to explain.
Sure.
My thought process is clear. So 189 and 2, 3, 5. Okay, so we would go through the first one on both. We would add these, we get 3, and then we make that our head for our new list. And then we would go to the next one and we do the same thing, except this time we get 11, right? So we would actually have to like mod, what is this? Mod 10 or just minus 10, get this to 1 and keep a carry going into our next one. And then this same here, we would get 14 with our carry 15. We would do the same thing again, 5. We would break our loop because we would be at the end of both of these, and we would have this at the end. So basically, you want to iterate through the lists on each one, adding the 2 things. You check if it's over 10, say like to check if you need a carry or not for the next number, and you do that all the way through the list.
Mm-hmm.
Oh wait, can I assume these lists are of the same length or not?
No.
Okay, so we'll just put in a ternary operator, then assigning the digit to be 0 if it's not. So for example, if this was 1 here, when we go do this digit, we would just assign this to be 0 so that we don't get like an indexing error, like null pointer error. And then that would change this answer to 2. And then after we've iterated, we'll break, and then we'll do one last carry check at the end in case there's an extra digit. Then we would add on the carry if there was. If there wasn't, just return.
Sure.
And yeah, and that would be like O of n, O of n.
What's your time and space?
O of n time, and then if we're including the output linked list, then O of n for that as well.
Okay. Sounds good. Okay. Yeah. Go ahead and implement.
Okay. So we want to return listening. Do you want me to make the list node struct?
Yep.
Right. So I'll have a list node which will have list node next, pointing to the next one, and then we will have our integer value. Then we'll need our constructor. So we'll just do list node in v, and then assign val to v. No, it's not. That's not supposed to be it. And then that will be our thing. And then our actual function, we'll say, what should we call this? We'll say add linked list, and we'll take in 2 pointers. We can call this, I guess, L1, L2. And then what we're going to want to do is we will okay, so what we'll do is, well, L1 or L2. So this is checking that at least one of them is valid. we'll say first digit is equal to L1 val. I will say, actually, we'll have to do the ternary operator here. So if L1, then L1 val, else 0. And we'll want to do basically the same thing for the second list. And then we will get the sum of these two digits. Let's call it final D, I guess. Equals D1 plus D2. Then if final D greater than equal to 10, final D minus equals 10, and carry equal 1. Should initialize carry. Duh. So carry should initialize. Yeah, and carry is 0. Very good. Actually, here we're going to need to take into account the carry previously, so we should just do that. And carry equals 0, and then node. It's just going to be a dummy header node. Okay, so, and then once we have our value, we can do, actually we should create another thing. List node cur equals int, and then we'll set cur.next equal to a new node. Equals new list node, final D, and then we'll need to cur equals cur. So, okay, so what we'll do here is we come in here, we create our dummy header for our return.
Mm-hmm.
And then we loop through until we're done. We're going to need a final carry check outside that we discussed. So if carry, then cur.next is going to equal new list node 1. So yeah, we'll go through, we'll check if the lists are valid. If they are, we get their value. If not, we set to 0. We get the digit by adding them and adding a carry. If this brings us to 10 or over, we take away 10 as a carry of 1, else we set carry to 0, and then we can create the next node in our answer list. And then we move to the next node to iterate. We should also do that for both lists. So if greater than and so next. Yep. So I think this looks good to me. I think that this would work.
Let's do a dry run.
Okay. So maybe copy down these examples I made before. Okay, they didn't copy paste for some reason. Okay, I'm gonna do a dry run here at the bottom. So let's assume we have our two inputs, 1, 8, 9, and then we'll do 2, 5, 7, 1. So what's gonna happen is L1 is gonna be 1, L2 is going to be 2, L1 equals 1, L2 equals 2, and this equals So we we get we create our dummy node.
Sure.
So you can see and is equal to that. Cur is equal to ends. Actually, we don't need one track screwing. Okay, so we go into the loop. D1, it checks if L1 is valid. It is. So then D1 is going to be 1. And then same with D2 is going to be 2. Then we add 1 plus 2 plus 0. So we get 3. It's not greater than equal to 10. So we set carry to 0. And we create our next node. So then answer would be 0, 3. And we iterate all of these to the next. So it would be 8 and 5. And we enter the loop again. We check if they're valid. They are. Then we add them, and we get 13 this time. So this time we're going to take away 10 to get 3 and set our carry equal to 1. So now our answer is 0, 3, 3. And we iterate through to next. And we check again if they're valid. They are. So we get 9 and we get 7. We add 9 and 7 and our carry to get 17. It's over 10, so we're going to minus 10 to get 7. Set our carry equal to 1 again. And then create our next node, which is the 7, and iterate to the next one. Then we're going to check if they're valid again. L1 is not valid, so it's 0. But L2 is, so it's 1, and we still have our carry equal to 1. We add them, we get 2, less than 10.
Awesome. Okay.
And then we just create our last node. So here. And then we exit the loop. And we get that there is not a carry. So we return answer.next, which would be this 3 here, giving our return value to be this list.
Okay. Sounds good. All right. Good job on that. Let's move on to the next question.
All right.
So this one is, we're given a binary tree. We're given a bunch of binary tree nodes from 0 to n minus 1. And yeah, pretty much we need to return true if and only if the nodes that we are given form exactly one valid binary tree. So the input will look something like this. I'll show you the input and output. So yeah. So each node is here. So this would be node 0, node 1, node 2, node 3. This would be node 0's left child and its right child. Negative 1 means it doesn't have a left or right child. So return me a Boolean value if the input is a valid binary tree.
Okay.
Is exactly one valid binary tree.
Okay. When you say the left child for 0 is 1, does this mean like index 1, so the negative 1, or does this mean the left child has a value of 1?
Its left child is node 1.
Okay. So its left child would be node 1.
Yep.
And then that child 1 is a leaf because it has negative 1 for both of them.
Sure. Yeah.
All right. So return only true if there's only one valid binary tree. If node I has no left child, the left child will come to the right child. Note that these nodes have no values. Oh, okay. We only use node numbers in this problem. Okay. So we would obviously start from 0 each time, I'm assuming, as the root. And then it has the left and the right child. And then exactly one binary tree. So what would make it invalid? I'm guessing if there's a cycle, because I would like make it into a graph. Like if we went to 1 and then one of 1's children was 0, that obviously would not be valid. The exactly 1 though, let's see, how could there be more than one possible valid tree? 0. Given a binary tree. Does 0 necessarily have to be the root?
No.
Okay, so that's how there could be more than one valid binary tree, I'm guessing. And are all the nodes necessarily like one connected component?
No.
Okay. And for when you say only if all the nodes form exactly one, does that mean um, they all have to be like valid in the tree?
Yeah, exactly. It's not a
Okay.
forest, right? Like one, we're given one tree. Like
Yeah,
the
so
input is exactly one tree.
sure only one valid tree invalid if there's a cycle or if not all nodes in tree more than one. So the if then one would be root. Okay, so let's say we just assume 0 is the root and we start from there, and then it ends up being a valid tree. Is it possible for there to be a second valid tree? I don't think so. I think that if we like assumed an index was the root and then we checked and it came back to be true, I don't think it would be possible for another tree to also do it, because if all the nodes have to be in the tree, they all have to be connected, and there's like no cycles because to make it a valid binary tree, I don't see how there could be more than one possibility of a root. So I'm thinking maybe we just check, like iterate over and check if each index is a possibility. Um,
What do you mean by possibility?
so we would start at 0 and check if it could possibly be a root. So we just go 0 and then we check its left and its right children. And then we basically just make sure that we visit every node, so 0, 1, 2, and 3, without there being any cycle, and then that's a valid tree, I believe. Okay, so if we have 0,
Yeah.
and then its left child is 1, and its right child is 2, and then we go to 1 and 2, and 1 would be a leaf, and 2 has 3. This is poorly spaced out by me, but okay. So we have 0 and we have 1, 2, 3. So if we start at 0 and we go do this check and we realize, yep, we can reach every node without like, any repeat visits, which means like there's no cycles, then that means that we can just return true in general, because when we go to do our checks for the other nodes, for example, like if we try and check if 1 could be a possible root, that obviously won't be true given this tree because we have no way to get to 0. Same with 2 and same with 3. So I believe as soon as we find the first possibility, we can just return true. I don't think it would be possible for there to be more than one possible root,
If there could be
given
more than one possible root.
I don't think there could be, because for it to be a valid binary tree, there has to be no uh, no cycles and have all the nodes in the tree,
Yeah,
correct?
exactly.
Yeah, so I think we can just like basically go through and check, is this one a correct possibility? And if it is, then we return true. And if it's not, we continue through and check. And then if we go through all of them and none of them fit, then we return false.
So for each one, what do you mean by possibility? How do we check right away that if it's a possibility? And what do we mean exactly by that?
We basically kind of like DFS. Like I guess we could do 0 and then go to 1,
DFS.
and then we try to go to 1's left child it's null. We try to go to 1's right child, it's null. So then we go back up to 0, and we go to 2. And we try to go to 2's left child, it's 3. Then we go to 3's left child, it's null. We go to 3's right child, it's null. So go back up to 2, go to 2's right child, it's null. And then we end up back at 0, and we visited everything, and there was no cycle. So it's a valid tree.
Okay. So let's see. Okay, so your algorithm is you're gonna do a depth first search on 0.
I think so. Let me think about this for one more second. We go to 0. And then we do 3. Should I think? I want to do a BFS, but yeah.
Does it matter?
No, it doesn't matter. I just want to code a BFS instead of DFS.
Okay. How are you gonna run the BFS on the 0th node again? I think like the question
Yeah,
still
what
holds
I'm
regardless.
thinking is like we have like our initial function, and then in the initial function we loop like for I to N or whatever, and we call BFS on I, and then we basically do like if BFS I return true, and then but if it's not, then we just keep going and trying. And when I do BFS I, BFS would be like this. It would be like in root, like we start at do BFS starting from that root, basically.
Wait. Okay. What's your time? Okay. If we and then what? What does the BFS do? Like could you explain that?
Yeah. So let's say our root is 0. Then we obviously push 0. We visit 0. And we go to 0 and we check its adjacents, so 1 and 2. So then we have
What's the return
Q.
signature? Like, what is it gonna return? True or false? You mentioned.
Boolean.
Okay. When is it gonna return true and when is it gonna return false?
True if once we've exited the like BFS loop. If if visited if visit equals 0, we'll initialize init visited equal to n, and then as we visit nodes we'll decrement it, and if it's 0 by the end and we didn't have a cycle, then we will return true.
Okay. So if we visit every node and we didn't get a cycle, we return true.
Yes.
From the BFS. Okay. What's your time complexity?
So BFS will obviously be O of n, like where n is the number of nodes, and then but we are potentially doing this with each index as the root, so I guess technically n squared.
Okay. Let's come up with a more efficient solution.
So how do we check if there's a cycle and if all nodes are in the tree? Do I just do top sort? Can I do that?
Top sort?
Like topological sort.
What? Okay. How would you? What would you do with the top sort? Like being able to figure out, like, what's your goal of doing the top sort?
Just check that the in degree of each node is 1, and the in degree of the except for one node, which would be the root, which should have 0. I guess we won't need to do this. What if we iterate Okay, we iterate over the list, like left child. We iterate over this, and hmm, yeah, we iterate over this. Iterate over child list. Check the frequency of elements all equal 1, except 1 that equals 0, which is the root. Do you understand what I'm saying with this approach?
Yep, you're iterating all the child and checking the frequency of all elements. Like what you're trying to do here is just find the root or any root.
Yeah, so basically we'd iterate over like left child. We'd make the count of like 1, 1. We'd skip over anything that's -1. We'd make the count of 3, 1. Skip over -1. Then we'd go over the right child list, doing the same. And then obviously this would make 2 to 1. And then in the end, we would do a final iteration over this list, and we would make sure that one of them is 0 and that the rest of them are 1, and then return true or false based on that. And that would be O of n,
Okay,
or yeah, O of n.
sure. Let's try that.
Okay. So we will return a rule, and let's just, what should we call this? Check it.
And for coding, we have about 10 minutes left. Like
All
seven
right,
minutes
let's
left.
do
7 minutes
check
left.
tree, and then we get int n, and we get 2 lists. Vector int left child, vector int right child. And then we'll do an order. No, we don't need a map. Vector int frequency, we'll get n 0, n 4, n right child. Frequency at n plus plus. So we'll just do that, and then we'll do the exact same thing for everything in right child. But actually, if okay, that. And then we'll do for int 0 is equal to 0. And then we want to iterate over the frequency array. So for in f in frequency, if f equals 0, I'm going to change this to a bool. False. Okay, so if the frequency is 0, if we've already seen a 0, return false. Else we will just set 0 equal to true. And then else if f equal 1, then we don't need to do anything, so we won't check that actually. But if it doesn't equal 1, then we also return false. And then if we get through all of this, we will return 0. And I think that should be the O of n solution.
Okay, walk me through it. let's work through a case, like the
Okay.
initial case.
Well,
Yeah.
okay, we'll do the one from here. Let me paste this down. So we go in, we initialize our frequency thing. So let's do this 0, 0, 0, 0. And then we go through our left child list. So the first one is 1, so we increment it, and then the next one is 3. Yeah,
Wait,
3.
what's the
So
frequency? These are the frequencies that of like each
that we
node. Zero.
see in child list. Yeah, for
Okay.
each node. And
Okay.
we skip negative ones. And for 2, we increment that to 1, and we skip the negative ones.
But
And
for
then
zero, how come we didn't increment? Okay, I see. I see. You did. Yeah. Okay.
yeah. And then we get to our loop here with the bool 0 equals false. So then we go through the loop. Our first frequency will be this 0 here. So we'll set 0 equals to true. And we go to the next element. And then we're at this 1. And it's not equal to 0. And it is equal to 1. So we do nothing. Same with this element. And then same with this element. So we break out of the loop. And we make sure that we have seen a 0. So it's a tree. And then that's it.
So okay, we're returning 3 because there's exactly 1 0.
We're turning true because there's
True.
one
Okay.
0.
What if we have a cycle though? What if this is pointing back to 0? What's gonna happen there?
Then there's ones, and then we return false.
Okay. What if this is pointing to 2? Sorry.
Then this would be 2, and we would also return false.
Where?
Here, if you see where line 102.
Okay. So we're able to catch cycles.
And then
What if there was a bunch of fours, like all of them had -1?
then so let's say we had 2 zeros like this. So on the first 0 in this loop, we set our bool 0 equal to true, right? And then on the second 0, so on index 1 in the frequency array, when we enter this loop, it will say if f is equal to 0, and so it'll enter here, and it'll say if 0, so we have already seen 0, and we return false.
Or did okay? Let's see. I think it would work. I don't know if I catch an edge case. I'm seeing any edge case here. Let me see. Because no one is doing it this way though on the solutions. I didn't do it this way. Let me think. If there's an edge case.
Is there another O of n way?
Me. Let's see. LeetCode Hard. This question is 1361. Let me throw this into GPT. Let me just make sure it actually works. I haven't seen this. Okay, let's actually work through it though.
I feel like there's an edge case with not all the nodes being connected, but I can't think of
all the nodes.
an example that disproves it.
Yeah. Like we walked through the. Okay, can you walk me through all the different cases and let's verify each one? Like.
Okay, so we've gone through cycles. It can definitely catch cycles. It can also definitely catch when 2 of them are 0. Okay, what's the edge case it would be with components? So what if there were 2 separate trees? Like 0 went to 1, 2 went to 3. Then they would both be 0, so it would return false. So what if? Okay, what if there was? Yeah, there's one entering, and then one is the node.
Okay, wait. Let's see. Like, what if we? Yeah, let's work. Let's have like a two forest. Let me think this. Like, we have a.
I'm trying to think. If there's two separate trees, it would also still work because it would. There, two of them would have in degree of 0, and then it would fail. Like it would return false.
Oh no. What if we have three pointing to four kind of thing? Here, do you see my thing right here?
Where are you on the coder pad?
Go into the drawing. Go into the
To the
drawing. I think I found
drawing.
the edge case.
How do I do that? I don't see drawing. Oh, sorry, on the left side. Okay. 3 to 4. Okay, so 0. Yeah, 0 goes to 1. So 1 is a count of 1. 3 has a count of 1. 4 is a count of 1. Yeah. Okay, this is edge case.
Mm-hmm. That's gonna capture it. Yeah. I was looking. I was like, there must be an edge case. Like, never seen this solution for it, but I think yeah, it's
Hmm.
definitely an edge case.
So
That was creative solution. Can't lie though.
Well, what is the optimal solution? Is it O of n?
Yeah, well, like I think you were getting it close because we're out of time. So what I would say is like, the optimal solution is find a root that could be any root by finding anybody with an in degree of 0, and then just doing a BFS on that one.
Okay, so it was a combination of the two different solutions I came up
Yeah,
with.
exactly. Were figuring out how to find the root, then you found it, and then you almost had it, but then it was just like, okay, find any root and then just BFS on
That's interesting. This is a good question.
it. Yeah, like it helps you think of graph theory a bit.
Hmm.
I just came out of, I got asked this once, so I was like, oh. I flopped it too. It was a new grad interview. And I almost thought of, my same problem was like, I couldn't figure out what the root was, or like which route to BFS on, kind of thing.
Yeah, because you can solve it with the BFS, but it's like the n squared.
Yeah, like where I failed was
Yeah, and
like,
then
okay, I assumed 0 was the root as well. Then I was like, okay, how do I find the root? And I kind of flopped that. But okay,
yeah, I knew it had the in degrees. You could find the root, but I wasn't sure how to connect that back. Ah, I should have connected the solution. Yeah, that's a good question.
cool. How do you think you did?
Um, I mean, like on a scale 1 to 10.
Out of 4, would you pass yourself?
I guess it depends how the other candidates looked, but if it was a straight up, maybe like a 2. To be honest, wasn't very happy with my performance on the second question.
Hmm. I think you did really good on the first question. I mean, everyone in the chat was like, "This guy's cracked. This guy's cracked." That's why I had to step it up on the second one. I think the second one
Hmm.
was like definitely. I don't think it would actually fail a lot of candidates. I would probably give you like a lean higher. I would like with your case. I'd be like, okay, maybe I just asked him an edge case question because you were pretty good on the first one. It's like, what if I can ask him? I would do like a follow up interview just to make sure that we don't accidentally miss on you. But okay, what you did well, yeah, it needs more signal essentially because I think that definitely needs more signal, but it's definitely close to passing. And I wouldn't just fail you right away because you did really good on the first question.
What does needs more signal mean?
Like I like I can't make a hiring decision because it's like
Okay.
we don't know if I accidentally gave you a bad question that you might not solve or you actually lack some problem solving skills. Like I couldn't really get that signal, right? Because
Hmm.
this one's a bit of an edge case question. You were like problem solving it to some way, but then you got locked into that one solution. And I don't think, like, I think if I gave you more time, you might have been able to lock out of that solution. But I think
Hmm.
it would have been hard for you to find that edge case I found, kind of thing. So it
Yeah.
just needs
I
more
knew there
signal.
was an edge case similar to that. I couldn't think of it though.
Mhm. Okay, let's see the feedback. I think you clarified the input and output well for the first question. You discussed the working approaches. You coded the optimal solution. The code that you wrote reflected your approach, and you had really good autonomy in the first one. I literally didn't say a word, which is good. So I actually give you a strong yes on the first question. Second question, you clarified well too, right? You figured out the input and output. You figured out the cycles. You figured out that the root is not necessarily going to be zero. Yo, coding with Minmer, thank you. Guys donated. But sorry, what I was saying, you clarified that the root is not zero, which is good. And then the main thing why I would give a no on the second question is because you couldn't get to optimal solution, but you did show you had problem solving skills, right?
Hmm.
So I think yeah, just seeing more questions. Like I think you've already seen a lot of questions. This is probably one that you didn't see before, but yeah,
Hmm.
I think overall like strong yes on the first one and a no on the second one would even out to like a yes, but I would still want to to do like one more interview, kind of thing,
Yeah,
just
that's
to see.
fair.
Yeah, but that's kind of my feedback. What do you think?
Yeah. Yeah, I think it's fair. So you don't think there's anything specific I need to do better? It was just if I'd been able to get to the optimal solution more so, but the problem solving, like the clarifications and stuff, were all fine.
Yeah, yeah, like really good problem solving skills as well. Like, okay, how do we figure out a route? Oh, you figured out like how we're trying to do a route. You figured out the BFS. I think overall, like generally, I just wouldn't be able to pass you because you didn't solve the question. I
Yeah,
didn't
that's
see
fair.
any issues with anything else. Your pacing was good. Um, you walked through examples. Your dry runs were good. I think run your interviews exactly like that every time, and you should always like pass. I feel it's just more make sure that you get the answer, optimal solution, and that just comes with more practice.
Mhm. All right, perfect. Thank you so
All right,
much.
man. All right, I'll catch you.
I got you. See
See
you.
ya. Coding with Minmer in the building. Congrats on 1,000 subs. Congrats on 1,000 subs. Super cracked. Yo, Paul, is this live? No, I'm just kidding.
I don't know, man. Might be AI.
What's up? What's up? How you doing?
Doing all right. I didn't sleep last night because I like messed up my sleep schedule, so I had to fix it.
What happened?
I don't like. I was doing homework on Friday night, and I just like I wanted to finish it, so I just stayed up until like 9 a.m. and slept.
Nice. Okay, wait. What's up, someone? How was that last question? What do you think about that last question?
I've done that question before. I think it's
Ah, I
cool.
see. Yeah, it's interesting. How's school, man? Like, when do you graduate?
Like next year, I
God
think
damn.
next year in either May or probably August. Actually, I think I will need like one more summer class after next May.
Let me see. What course are you taking right now?
I'm taking networks and uh, robotics AI.
Yeah. Bro, what's that? Is that a fire alarm in the background? What's that? Like
Me?
buzzing. Yeah.
It's probably just my mic being
Oh, I
crap.
see.
I can try to fix it.
Okay. Chat's gonna roast you if it's a fire alarm or something. I'm just
One
um,
sec. I could probably fix it, I think.
yeah. It's like a little.
Is it only when I talk or is it just in general?
see. I don't even know. Wait,
Well, I'm
it
just
just
gonna
comes
search,
randomly.
like,
Yeah, I'm
just
gonna find you
search,
some
like-
good questions. Do you do C++
Alright.
too or Python?
I I haven't coded in C++ in like 2 or 3 years.
Okay. Yeah, I remember. Yeah. How do you think about the people so far? Who you giving the highest rating to?
1 sec. Is my
Yeah.
mic up?
Yeah, it's better. It's better.
Okay. I don't know. I think that the Waterloo kid, he's pretty correct.
Yeah. What about
You
Russian
guys
guy?
definitely. A Russian guy, I thought he was okay, but I didn't like. You gave him easy questions. To be fair,
Did I?
I thought they were easy. Maybe just because like I don't know.